So the second part of your quiz is your no calculator portion, and then it does say that you have to show all your work to support your answer, and then make sure that you're writing it in that form A plus BI. Okay, so this is your no calc section. Okay, so when you simplify, anytime you have a negative, that's where the I comes in. Some of you might know what that is, but what the perfect square is. But if you start doing a factor tree, you find prime numbers that go into them, and the two prime numbers you really want to start with are 2 or 3. So 2 goes into this. We know that because it's even, right? So if we cut 98 in half, what do we get? 49. And then look, recognize this. This is a perfect square. Okay, if you guys need to write down your perfect squares so that you're familiar with them, you can. To find your perfect squares, you just have to start squaring numbers. You never have to check for 1 because anything times 1 is itself, but 2 squared is 4, so 4 is a perfect square. 3 squared, 4 squared, 5 squared, 6 squared, 7, 8, 9, 10. Okay, so these perfect squares, we definitely need to know those. All right, so once you see the 49, then you can just write this as I square root of 49 times the square root of 2, because 49 times 2 is 98. This can only come outside a radical if you can take the square root of it and get a whole number. Okay, so it only comes outside the radical if you have a perfect square. All right, and then for B, you cannot multiply those together. Remember, this only works if these are, if you have a positive. So you have root 12 times root 8. Okay, and then you guys can decide from here how you want to do this. If you want to multiply those together, again, you won't have a calculator, so you would get 96 and you could factor tree. Or you could also just simplify each one separately, because many of you know that the perfect square in 12 is what? What's the perfect square in 12? 4. So it's root 4 times root 3, right? Square root of 4 is 2, so you have 2i root 3. What's the perfect square in 8? 4. So it's root 4 times root 2. So then you have 2i root 2. And then from there, you just have to multiply the outside values together and then the inside the radical values. So 2i times 2i is 4i squared. Root 3 times root 2 is root 6. And then what do you plug in for I squared? Negative 1. So then you have negative 4 root 6. Okay, again, that's not the only way to do it. So if some of you did the 12 times 8, and you got I squared is equal to 96, this is where you can start to factor tree. So you can start, it's even, cut it in half. So 2 and 48, that would be 2 and 24, that would be 2 and 12, 2 and 6, 2 and 3. Now the rule is, if you have a pair, they can come out. Okay, so I have 1 pair of 2s, 2 pair of 2s. So I would have on the outside 2 times 2, that's how you get the 4. Inside is 2 times 3, that's how you get the 6. And then the I squared turns into your negative 1. Okay, so there are multiple ways to do that and be successful. Okay, with C, you have to do the power of 2. So if you have an even number, you can write it as a power to a power. Okay, so if you cut 26 in half, it's 13. And then anytime you have I squared, you're going to plug in negative 1. So negative 1 to the 13th power. Is that going to be a negative or a positive? Negative. Anything to an odd is going to be negative. A negative to an even root is going to be positive. Okay, and then remember yesterday we did one with an odd exponent. If you have an odd exponent, you just multiply it by I. Okay, which we're going to see in this one. Okay, so for D, we're going to multiply these together. Okay, so you can do I like to do the bigger numbers first because I know that that's going to be 48. And then we're going to do 48 times 3. Okay, so I have positive 144 because I have a negative times a positive times a negative. I to the third. Remember, I to the third, you're going to write as I squared times I, so that you can plug in -1, and that's how you get negative 144I. All right, and then for this one, you have to do the exponent first. So when you're doing your order of operations, just make sure you understand this is -7I times -7I here. That's how you get positive 49I squared. Okay, and if you want to, at this step, you can plug in -1. Okay, so it'll be -4 times -49. Does this problem feel familiar to you? Yeah, it's one that we did in our notes. Okay, so if you do 4 times 49, remember how we talked about different strategies to do that? You could do 40 times 4, and then you could do 9 times 4, and add them together. So you get 196I. Negative times a negative is a positive. Okay, so that is your final answer. Okay, any questions for me on that one? All right, and then for 10, you are going to solve the equation. When you are solving, you should get a value for x. Okay, and then if you're somebody that knows, like when you've been doing your test, that sometimes you miss a negative here or there, I do recommend making sure you write out the step where you move it over. Okay, and then -90 divided by 5, and if you need to, you can go ahead and you can do this. Do you guys know what 5 times 12 is, though, off the top of your head? Yeah, so you know it has to be bigger than 12, so you can kind of use that. And then, sorry, so 5 goes into 9 one time, so you're going to subtract and get 4. 5 doesn't go into 4, so you bring it down. 5 goes into 40 8 times, so you get 18. And then because you have a negative divided by a positive, it'll stay negative. Okay, now this is one where I feel like people forget the plus or minus. So will you just double check that you remembered that part? And then if you have 18, you can either factor tree or you can find one of your perfect squares. So a lot of you know that 9 goes into 18. Okay, don't break 18 up into 6 and 3 because that's not going to help you. Can you take the square root of 6 and get a whole number? Can you? No. Can you do that with 3? No. So the reason why you want to use 9 is because that's going to give you a 3. So then you'll have 3I root 2. Okay, so that's why you have to have the plus or minus for this, because you're solving. So if it's asking you to solve, you've got to have that plus or minus. Just circling that for emphasis. All right, and then for these, make sure that you're adding the like terms together. So 4 and 3 is going to be 7. 2 minus 7i is -5i. Anytime there's subtraction, I distribute. That just helps me make sure I don't make any simple mistakes when I'm subtracting. And then you can combine your like terms. 3 minus 4 is -1. 11 plus 6 is going to be 17i. Okay, and then for C, you are going to FOIL. Okay, so 2 times 5 is going to be 10. I like to do the inside and the outside together so that I can combine my like terms. Okay, so -15 plus 14 is -I. and then negative 3 times 7 is negative 21. I times I is I squared. And then you're going to plug in negative 1 for I squared. Okay, so you have 10 minus I plus 21, which is how you get your 31 minus I. Okay, and then for part D, you have to multiply by the conjugate. So what I'm looking for is you know the correct value to multiply by. Okay, so the conjugate is of the denominator, and whatever you multiply by should result in a cancellation. Okay, so negative 60i and 60i are going to cancel, and then you have negative 100i squared. Okay, once you plug this in, you are going to add those together. So you get 136 on the bottom. When you distribute on the top, you're going to get 24 plus 40i. And then you have to write this in a plus bi form. Okay, so we're going to break these apart and then we're going to reduce. If you're reducing without your calculator, make this as easy on yourself as you can. So yeah, 4 might go into both, but that might take a little more brain power. What can you do very simple that's going to go into both of those? 2, because they're all even numbers. And isn't that going to be a little bit easier to just cut things in half? Right? This would be 12. Half of 100 is 50. Half of 36 is 18. So you just add them together. And then if you cut those in half again, 6 over 34. And then you can cut them in half again. Yep. And you just keep going until you can't go anymore. Okay, so here you have 20 over 68. Okay, cut it in half again. You have 10 over 34. Cut it in half again. 5 over 17. Okay, so anytime it's an even number, you can divide it by 2. Make sure everything you have is in the reduced form. Okay, that's your simplest form. Okay, and then for this one, you can multiply the top and the bottom by 3i. That will give you negative 9i squared. When you plug in negative 1, becomes a positive when you multiply. And then we're just going to distribute here. So you have 12i minus 6i squared. Again, you plug in a negative times a negative is a positive. Now, why did I switch and put this in front? Why does that matter? Exactly. Your final answer has to be in the a plus bi form. So the real number goes first, the imaginary term goes second, and what goes in really to all of these? 6, 12, and 9? 3. So if you divide by 3, you will get your final answer. Yeah. Yes, so the only reason why it's incorrect is so that it's in the a plus bi form. So you want your real number separated from the imaginary term. Right? So if you got that far, the most I would take off is a point, and I would just cite the form. Okay. Okay, good. Any other questions for me on those?